Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra 2 notes. So today we're looking at the second part of 8.4, and really today we're going to build up to this graph. All right, we're going to graph logs today. We have to get into a little bit more about kind of moving some things around with logs and kind of working actual mathematically with logs. But then in the second part of the notes here, we're going to talk about, hey, how do I actually graph them? All right, so to start us off here, we got to look to find an inverse of log and exponential functions. All right, and we've talked about finding inverses, and the main thing that we talked about finding inverses, I think we did it in chapter 7, is that the main thing we did is we switched the x and the y. All right, so switch the x and the y, and we're going to do that again today. All right, and then once we switch the x and the y, then we solve for that new y. But there's going to be one step in between here, and that's going to be to change the form. Okay, so to find an inverse of a log or an exponential function, you have to first switch the x and the y, then you have to change the form, and then you have to switch and solve for y. All right, awesome. So here we go. It says find the inverse of the following function. So it says, hey, let's go first. Let's switch the x and the y. So I get x equals log base 8 of y. All right, all I did, switch the x and the y. Okay, now I have to change the form. All right, so change the form. It is in log form right now. I have to make it into exponent form. So my exponent form, remember, the 8 is the base. I always raise it to whatever's on the other side of the equal sign, which is x, is equal to y. All right, and there I look at, hey, now I have to solve for my y, and look at my y is all by itself, so I am good. All right, example number 2, a little bit different, a little bit kind of the same way, but a little bit different at the same time. So now switch the x and the y, so I get x equals, and instead of writing ln, remember how we talked about that's log base e of y minus 3? Okay, so I just wrote ln of log base e, okay, because now when I switch the form, so now when I go back up here to change the form, I raise it, I go my base first, so I go e to the x is equal to this y minus 3. And notice how my log goes away because I'm changing it into exponent form. And my last step here to get y all by itself is to add the 3, so I get e to the x plus 3 is equal to y. All right, awesome. Going on to example number 3, this one is a little bit different because it's in exponent form. So now this one, you have to switch the x and the y, so I get x equals 2y plus 1, 2 to the y plus 1. Okay, all I did there was I switched the x and the y. Now I have to switch the form. So now when I switch the form into log form, I got to make sure I put in a log in there. My base of my log is going to be the base of this exponent, so that's 2. And then I have my x is equal to y plus 1. Okay, kind of a little trick there is that whatever this y is, that always goes on the other side of the equal sign because you're going to end up having to solve for that, right? So that always goes on the other side of the equal sign. So now I just minus 1, so now I get log base 2 of x minus 1 is equal to y. Okay, awesome. There we go, there we go. Switch the x and the y, change the form, and then solve for y. Okay, and the next one is going to be huge, 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 huge. The change of base formula. Okay, so remember how I talked about in your calculator you only have log base 10. Okay, so now we're going to talk about, hey, how do I plug this into my calculator if it's something that looks like example number 3 here? All right, and the way that we do that is if I look at this, log base c of u, notice that my u is on the top, so I have log base, let's just say 10. Let's just say 10, and then the c goes on the bottom. Okay, so the way that you can plug this into your calculator for example number 3 is this is going to be log base 5 divided by log base, or excuse me, not log base 5, log of 10. Whoa, hold on there. Log of 5 divided by log of 2. So always the base goes on the bottom of what you're dividing by. So now you can put this into your calculator. You can go log of 5 divided by log of 2. And that's nice. That's going to help us with a lot of things as we move on here, is that you can go through and just find that. So I got log of 5 divided by log of 2, and as you plug that in your calculator, you should get 2.322 about. All right. All right, awesome. And the last quick kind of example here we have is we can plug this into our calculator, log base 7 of 20, but you plug it into your calculator, you do log of 20 over log of 7. And when you plug that in your calculator, you should get 1.540, somewhere along those lines. Okay, so make sure you can get those numbers. That changing of the base is going to be huge. That's going to help you plug those things into your calculator that aren't very nice. All right, awesome. So here we go. Graphs of logs functions. All right, here's the main function here again. So notice how we have an h is inside the parenthesis and the k is outside the parenthesis. So again, we're going to go through and graph my parent function, and then we're going to move it with my h and my k. All right, and the log functions look like this. So I'm just going to draw kind of a little sketch here. Now the log functions get really, really close to my y-axis and go this way. Okay, so you should see the difference in my exponential growth and decay is that this was growth, this was decay. These guys get really, really close to the x-axis. Now this gets really close to the y-axis. All right, awesome. So when making your table for the graph, there's a couple different things here that are going to be key when we're graphing. The first part is change the parent function from into exponential. So change the form. Okay, so that's going to be key in the first one. We're going to change the form. And then we're going to compute the y values first. And this will make a little bit more sense when we look at an actual example of why we plug in the y values. All right, so now then, of course, we just plot that parent function, and then we do the shifts with my h and my k. All right. So hopefully this will be make a little bit more sense when we go through and talk about this. Okay, so it says graph the following functions. This first one is just log base 3 of x. Okay, so log base 3 of x, my first step is to switch form. All right, so my first step is to switch form. So if I take this is just my parent function. My h equals 0, my k equals 0. So if I switch the form, this is going to be 3 to the y is equal to x. So I remember I raise it to whatever's on the other side of the equal sign. And now this should start to make sense, is why step number 2 is to plug in y values. So most of the time, normally, we plug in -2, -1, 0, 1, and 2. We plug those in for my x values. But now we're plugging them into my y values here of -2, -1, 0, 1, and 2. And we can kind of cross off that last one. We don't really need it. All right, so now hopefully this should make some sense, because now when I plug in 0, 3 to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the -1 power is 1/3. And then this is 1/9. All right. Those guys flip around. 3 to the -1. Remember, that guy goes to the bottom. 3 to the -2. That guy goes to the bottom as well. All right. Awesome. So now I have to go through and graph these. All right. And be careful. You still graph x comma y. Even though you plugged in your y's first, does not mean you go yx. So that's the kind of common mistake that a lot of people make. So now when I'm graphing this, I go over 1/9 and down 2. So that is right here. Over 1/3 and down 1 is right there. Over 1, 0 is right there. All right. Over 3, 1 is 3 up 1. Then I have 9, 2 is right there. So notice how this graph comes in, and now it gets really, really close to that y-axis, but does not go past. So now my vertical asymptote is x equals 0, okay? And that is why this domain and the range change. So now with my logs, they kind of always, when I think of logs, so I'm just going to put my little third step here that I forgot, move with h and k, but this time I didn't have an h and a k. So now with logs, I kind of think of that everything is different. So I switched the form, yes, now I have to plug in my y values. That's different for what I did for exponential growth and decay. And then now my domain and my range change up. So now my range is y equals that fancy looking r. There is no horizontal line that this gets really, really close to. But there is this vertical line right here that this gets really, really close to. So now my x has to be greater than 0. Okay, so notice how I always graph when it's greater than that 0. Okay, so that's why my domain and my range kind of switch around there. All right, awesome. So example number 6, this one's got all the whole shebang in it. So let's go through and see what we can find here. Number 6, I like to just square in my parent function. Now, again, switch form. So now I switch the form of this guy. So now I have 1/2 to the y is equal to x. All right, remember, number 2, plug in y's. All right, so I'm going to plug in my y's in -2, -1, 0, 1, and 2. All right, and see what these guys shoot out. So I go 1/2 to the 0 power is 1. 1/2 to the first power is 1/2. And 1/2 to the second power is 1/4. Again, plug those guys in your calculator if you don't know. 1/2 to the -1 power actually switches this guy around, so that's going to be 2. And then this one's going to be 4. All right, see kind of the resemblance there with that 1/2 and the 2 and the 1/4 and the 4. Okay. All right, so here we go. As I go through and just graph these now, so now I go 4, -2. So 4, -2 is right here. 2, -1 is right there. 1, 0 is right here. 1/2, 1 is right here, and then 1/4, 2 is right there. So be careful. Again, you're graphing your x, comma, y. You're not doing y, comma, x. You have to make sure you graph these points. Like this point here is 4, -2. All right. Awesome. So here we go. This guy, your parent functions always get really, really close to 0. And then it goes like so. But now I have to make sure that, hey, I move with h and k. So now as I move with my h and my k, I know that, hey, my h equals 2, my k equals 4. Remember, your h is what's the opposite of what it looks like, so that moves it right 2 and up 4. So I have to move every one of these points right 2 and up 4. So I go right 2, up 4, 1, 2, 3, 4, right 2, up 4 is right there. Right 2, up 4 is right there. Right 2, up 4 is right there. And right 2, up 4 is right there. So now you have to be really precise, is that this line gets really, really close to 2 now. And then goes on and on forever. That's not a very straight line. It's pretty squiggly, but you guys get the gist. So remember here that this line gets really, really close to this 2 now and does not go past. All right, so it gets really, really close to that 2 and does not go past. So that's my vertical asymptote. X equals -2. All right, and, or excuse me, +2. I don't know why I said negative. That would be a positive. All right, and my domain now is x is greater than 2. And my range is that fancy looking R. That's the all real numbers, because there's no horizontal line that it gets really, really close to. Okay, awesome. So again, we're going to do a lot of examples of these, of graphing these log functions. So thank you for listening and getting the gist here. But I promise you that these will start to make a little bit more sense. I just kind of always like to think that log is kind of the opposite of what you think. So again, you don't plug in your you don't plug in your x values. You plug in your y values into these guys, and then your domain and range kind of switch around. The range is the all real numbers with logs, and the domain is whether it's greater than or less than, whatever. All right, awesome. So thank you again for listening, and have a beautiful rest of your